Here you see a rather hilly piece of land we have, and we intend to put a road through the property from the northwest corner down through and across the centre of the property and down, exiting at the southeast corner. After some preliminary talks with the client, the area that we've just sketched with the cursor is the area that he would like the road to go through. So we will show you how to start from this raw data or raw model and proceed through to design a road. The first step in the process is to fix the horizontal location, and we will add in some horizontal intersection points by simply adding points onto the contoured surface. So select points, add points. It's a good idea to start your point numbering at an even 100 just so you can keep a track of them, and we will click in point 2100 in the area. We then move down towards the center and click in the next point. Again, we are working on putting in a rough alignment which may need to be changed later, but this alignment is simply following where the client has indicated he would like to see the road. So we will place the alignment through and then evaluate whether we can build the road economically along this alignment, and if not, we may choose to move it. Having established our horizontal intersection points, we'll now use a root curve function. So select COGO, curves followed by root curve. The string folder we'll use is road and an ID of CL. The spiral type can either be a clothoid or a Malaysian JKR. For all practical purposes they are effectively the same, except an extreme lengths of curve. Basically what you do is enter into the table the IPs. You will see that it calculates the distance. You then enter your transition in, the radius you require and the transition out, and give the curve a number. Repeat this for all the curves in the job, and on the last line where your exit IP is, you simply type in the last IP and then set the transition and the other values to 0, and when you click the apply button you will see that a string with the curves has been placed through the job. We could have set a layer to put these points on, but we forgot. So basically let's go and put all the points that we just calculated, the points from 2100 all the way through. Let's select those and we'll alter them and place them on a layer so they're easy to see. So points, select, then points, alter, and if we change the layer and replace it with, in this case we'll just use road CL because they're all on the road centre line, we can now use our layers function to set the display so that we can see these points more clearly. If we select layer and select road CL to display code, and then use modes to switch your display control to the layers, here you will see the string going through and you will see the points coded. If you turn off your contours you'll see it more clearly, and you will see what we call the frame points. The alignment points have been coded. TS is tangent to spiral, SC is spiral to curve, CS is curve to spiral, ST is spiral to tangent. These are one of the many quote standard end quote terms used throughout the world for designing roads, but they're the ones we've adopted within EasyCAD. Having established our trial alignment, the next thing we need to do is to interpolate profiles and sections. So first select the string, then go to contour, interpolate profiles and sections. When the table comes up, we wish to extend our natural surface sections a little bit wider than the default 20 metres. We'll take them out to 35 metres on each side because we could get into quite a bit of fill. We refresh the table, you will see the values filled in, and once we click the save button the process will start. It will scan its way through calculating the various sections, and in the bottom left hand corner you will see a progress report on what section it's up to. Once it's done you'll be presented with the values and shown the profile along section. If you wish you can use next or previous to run through your sections to see, but We're happy at this stage that we will proceed with this alignment, so OK and save. We'll save the points. You will see the progress bar showing you what's happening, and once the points are saved you can then see the additional natural surface points have been stored onto your model. We are now ready to enter some vertical grading onto this alignment. To get ready to deal with the vertical side of things, select Road, Display and Plotting, and Display Profile, then select it again and Display Section, then select Window and Tile Roadwork so you can see all three. Now we wish to add the vertical grading, and while you can do it in the small window, it's probably better to enlarge it, so maximise that profile window. If you right click in that window, a menu will appear showing you the available options, and we wish to add in vertical points, vertical intersection points. When you click on the first point, if the design line needs to be turned on, the program will prompt you to do so, and just select OK. And the process now is much like you used to do on a sheet of paper, except we do it on the screen. Where on the sheet of paper you used to eyeball in the vertical eyepiece on your profile, here we're eyeballing in some vertical eyepiece on the screen. Now, there are as many solutions to the correct vertical grading or suitable vertical grading for this job as there are designers and engineers looking at it. We're not particularly concerned with where we put the points, we're simply showing you how to put them. All we've done is simply gone through and continued to add vertical eyepiece where we think it might be reasonable. Once that's done, we will then refine this initial design. Our first refinement will be to add some vertical curves, so right click to get your menu and then select VC and point to the IP. You will see a table appear showing you the grade in, the grade out, the change of grade and some suggested values for different speeds. You can enter whatever value you like. The table is there as a suggestion, as an amalgam of various standards. Let's continue now to add VCs at the first few IPs. We have not elected to enforce any particular standard. What the values you see recommended are from an amalgam of standards used worldwide, which are all reasonably close to one another. But we find that the designer is allowed a degree of leeway. We've now come and we're ready to put in another VC. When we click on the IP, you can see that the one we put in was too long, so go VC again and reduce it back to 70 and you will see what's done. Now go to your next VC and attempt to put in a 70 metre VC. You will find that the program reports that it's too large, it won't fit, and the maximum is 47. So if we juggle the vertical curves at these two IPs, we simply select VC, point to the leading VC and pull it back to 60 metres, and then go to the next IP where the initial problem was, and we can now put that in as 50 metres and it will all fit quite nicely. The process now continues, and you should continue on and put VCs wherever you believe they're appropriate until you're finished with the vertical curves. You can zoom in on any section of the profile to see your design, and once we've zoomed in, let's have a look at the Move IP option, which is another way of refining. If you select Move, then grab your IP and drag it. You will see that the IP and the VC moves with you, and you can target this to touch the natural surface or miss it or be above it, anything you see fit. So you can move all the IPs around simply by selecting the option and then dragging them, and you will see instantaneously where they will appear complete with the vertical curves, although bear in mind that if you've changed the grade significantly you may need to alter the length of your vertical curves, but we leave that to your design experience. You should be aware that all the IPs and vertical curves you entered are stored in a table, so if you right click to bring up your menu and go Design IP Table, you will see a listing of all the values. If you wish to round some of these values off to even numbers, for example here we'll set the change to 0 and the height to 59, you can edit this table and the changes that you make will be reflected in your profile and in the design IP points. so you can refine the early click and point to enter in even changes and even heights if that's what you wish to do. Once the vertical grading is completed, you need to enter a cross-section template. So maximise your cross-section window and select right-click to bring up a menu and select Standard Templates. We now enter where we want the template to start, and the start of 0, 0 indicates that it will grab onto the vertical grading. Here we wish to have 2 lanes 3 metres wide each side of the centre line. Then bear in mind that the template in EasyCAD is the right hand half of what the finished design cross-section will be. So here we're simply going through and entering in the various legs. We've entered 2 lanes at 3 metres for a total of 6. We've then entered a shoulder of 1.5 metres at -4. We'll now enter a gutter of half a metre at -25% or 1 in 4. And then we'll use, rather than horizontal distance and grade, we'll use the go-to coordinates and the relative to tell it to construct a curb which is vertical, so the shift is 0 in the X direction and 0.2 in the Y direction. Now we will use horizontal distance and grade again to construct a path of 1.5 metres wide, sloping at 4% away from the road. And at the end of this path we need to check whether we're in cut or fill and react accordingly. So from your type, pull down and go down till you find fill condition, and for fill between 0 and 99, which is any fill, go to condition number 1. At the same time set a cut condition at this point and branch that to condition number 2. Basically this gives you the flexibility to alter the individual things later on. Once that's done, it's time to start condition 1, so go down and find start condition and tell it to start condition number 1. And condition number 1 will simply be a fill batter at grade. So select fill batter at grade, the distance of 50 metres or until it intersects the natural surface, whichever comes first, and a grade of 1 in 2 will be shown as 50%. Then start condition number 2. In condition number 2, if it's in cut, we normally construct a little catch drain. And what we will do for the catch drain, instead of using a horizontal distance and grade, we will actually use a fill batter. The only difference is that if the fill batter strikes the natural surface, it will stop. So if we find a situation where it's only in a small amount of cut and it goes off to construct this catch drain, then it will stop at the natural surface. So we use a fill batter at grade for 2 metres for a grade of 1 in 3, and then we'll use a cut batter to go back to intersect our natural surface. So cut batter for 50 metres or until it hits the natural surface, whichever comes first, for 1 in 2. And basically we've now finished our template, so we save it away and get ready to move on in the process. Next we need to position the templates down the road, so use your right click and select template positioning. In the first row, first column, enter template 1 to the left and right, and then right click on that and it will globally change all the following changes. Repeat for the right of the road, and when you save this you will see the template displayed, overlaid on your natural surface cross section. You should use next and previous to scroll right through the road. Basically you need to go and look at all these sections, just to eyeball them if you like that terminology, to make sure there are no major glitches. Again, you're not looking for where it misses by a millimetre, you're looking for where it fails to intersect the natural surface or things which will be readily apparent. You're looking for major glitches. Once you've had an initial look at the sections maximised, we suggest that you minimise that section window so that you can again see the 3 windows, and then proceed on to a complete review of the design as it stands at this point. The review process consists of looking along the length of the road and checking both the cross sections and the profile to ensure that there are no problems. Here you can see that we've obviously going to have some trouble through the major fill embankment, and we may have to reconsider that or put a bridge in. If we look in other areas, and you can either just click along the profile and you will get an indicative view of the sections at that point, and you can determine whether there's likely to be a problem by simply clicking at various sections on your profile. Let's go back and look at this major area of fill, and let's assume we don't wish to build a bridge, so we would need to add in another vertical IP. So with the profile window active, right click, call up add, and add in an IP to suit, and then obviously if you wish you would also put in a VC. Then you can look at your sections again, and you will notice that we have a problem here with the cut batter slope, which seems to be unable to intersect the natural surface. You can then highlight your section window, right click, and go to your standard templates, and you can change the batter slope. So here, whether it's right or wrong, it's just to show you how it's done. We'll put a cut batter slope of 1 to 1, and once we save that away and review the sections again, you will see that the batter slopes now intersect, or at least the cut batter slopes do. So the process continues, and you continue to review and go backwards and forwards between vertical design and standard templates. In this situation we can see where the fill batter is running parallel. Now you can either alter the fill batter, or you can change the intersection point for one or a few individual sections. So again, it's on your right mouse button from the section window, and it's changed intersection point. So if there's only one or two of these sections where the batter runs parallel, you may choose to simply change the left intersection point on those two and leave the remainder of the batter slopes as it is. Either way, you review the design, you go backwards and forwards making changes where necessary until you're satisfied that it is a reasonable design and you are ready to proceed. Once you are satisfied with the basic design, it's time to look at applying superelevation. So if you select Road, Design Criteria, you will see that there are two components, Edit Tables and Specify Curves. First we'll look at the tables. In EasyCAD, one method of applying superelevation is to set up tables, and we've supplied a number of them for you. These tables basically allow you to specify the length over which the super is to be applied and how it will actually be applied in 10 metre increments, in this case over the length of a 90 metre transition. You'll see here that the maximum superelevation, or the maximum side slope, will be 7% in the full curve, starting at 3% on the entry to the curves. This is table 3, and there are a variety of other tables supplied which can be used to cover standard curves, and you can make up your own tables to suit yourself to apply as much or as little super as you want. The other part of the superelevation is actually in identifying where the curves are. Because the curves can be specified in a number of ways, we provide a table and allow you to type in the start and finish changes. If you happen to have a string set up in the required format, you can obtain it from there, but ordinarily the strings have other points rather than just the transition or super points, so they are not suitable, and it is usual that you would inspect the string and take the values from there and type them in. In this case, where the alignment has been defined by the root curve, select the string, then select the points on that string, and then go to Points Listing and set it so that it displays the point number, the chainage and the code, and sort by chainage order. And when you have the list presented to you, the points you're interested in are the points which are coded TS and ST. You can either note those points down, or copy or cut and paste or manipulate them however you see fit to get a list of the applicable chainages. If you've used other means of calculating your alignment, you may not have points coded with TS or an ST. What you need to do, regardless of how the alignment was determined, is to prepare the chainages of the points that are at the start of the curve where you wish the superelevation to commence applying, and the end of the curve where the superelevation should finish and taper back to the standard crossfall. Once you have these values for each of the curves, you're ready to proceed and fill in the super table. In the super table, you type in the start chainage and the end chainage for each curve, and which table number you wish to use to apply the superelevation for that curve. If the curve is left-hand, you precede the table number with a minus sign. As you can see on this first line, we have a left-hand curve, so we've used -3 for the table number. Here we're entering in our second curve, and again the start is the TS point, or the start of super on that curve. The end is the ST point, or the end of super on the exit from the curve, and here, because it's right hand, we'll use table 3 on both. Once you click OK, you should now go and review your sections, and if you maximise the section window, you can clearly see that we have full super at this particular chainage. If you use your next and previous buttons to go towards through the curve towards either the beginning or the end, you will see that the super tapers off as it comes either in from or back towards a straight. Once you are satisfied that the design is in place and the super is applied, it's time to calculate the volumes of this particular design. Pull down the road menu and select volumes, and go to your design volume parameters. Click on the minimum and maximum buttons to update the fields, and you can then decide if you want stripping of topsoil. In this case, to show you what it does, we'll have 0.15 or 6 inches of stripping, and we go OK. If you look closely at your section, you will see where the stripping has actually been applied. If you now go to road and design volumes, the volume report will appear in your word processor. If necessary, change the format of the paper so that you can see it clearly, and if you scan through and check the volume at the end, you will find here that we have pretty close to an even cut and fill. So we're satisfied that this design is feasible. It may not be the one that goes ahead, but it's worthwhile proceeding at this point. The next step in the process is to store the design points, and you need to create a design surface for that. So highlight the contour window, then select contours, surface parameters, and add a design surface, which in this case will be surface 2. Once the surface has been added, go to road, design surface, and store design points. Once the table appears, you will see the points to be stored. You need to enter a string folder if you wish to have the strings of the various elements in the template stored. Once that's been entered, press the save button, and the points will be stored, and you will see the strings formed and shown on your plan view. At this stage, we should look at contouring this design surface just to see what we've got. So select contour, go to surface parameters, and set your maximum distance along the edge of a triangle to about 60 or maybe even 65 meters, so that you don't get triangles across the concave areas of the curves. Then form your model, and once the model is formed, you will see that we have the design road covered. So calculate your contours, and once the contours have been formed and saved, you can zoom in and pan and zoom along the road and see exactly what is being proposed in this design. If you look closely at your contours as you zoom along, you will be able to identify any potential drainage problems or other glitches that may have escaped your attention in the sections. But presuming everything is fine, you will move on and create a combined surface. Once the design has been successfully stored, we wish to create a combined surface. So choose Surface Parameters and add a new surface, make it combined, and that will be Surface 3. Then choose Road, followed by Design Surface, followed by Create Combined Surface. You could have also chosen Contour Merge Surfaces, it goes to the same point. Click on OK, and you will find that the program goes off and merges the natural surface with the design surface to create a new combined or as-built surface. Once that's done, pull down Surface Parameters, maybe change your contour intervals to 10 and 2 so you're not completely swamped with contours, and then form the model and calculate the contours. If you zoom in, you will be able to see the road cut through the natural surface, and the plan you have in front of you is a combined or as-built surface. Once you're satisfied with this, we can move on and show you how to get a 3D view of this. We are in the early stages of developing a 3D view package to go on top of the contours. At this stage it is in its developmental process. It is supplied as is, and if you wish to use it, feel free to do so, but we accept no responsibility for the time you're likely to waste. Having said that, call up the contours, select 3D views. Right click in the 3D view window, and don't worry that you can't see much at this stage, and click on face first to fill in the face of the triangles and the surfaces. Next, click on Flight Path Table. What we want to do is to set up a table of an alignment to follow. We will use the strings, so pull down and select the folder you stored your design strings in, and select the line that was the centre line or the alignment. In this case it was New Road and line 7. Once that's done, you set a distance between the shots, and here we'll use 50 metres, and then click on By String to fill the table in, and then click OK. And this will store away a record of where the program is to take pictures. Right click again to call up your 3D menu and click on Flight Path. At this point, be prepared for a delay, and the delay will be in direct proportion to the speed and grunt of the computer you've got. But once it's finished, it will bring up the 3D view and start marching along the road at the 50-metre interval and displaying for you the road as you go. As we said in the early stages, it's in developmental stage. Play with it if you like, have fun, and print it out and display it for your clients. If you have any suggestions as to how we can make it better, we're prepared to listen, but it is supplied at the moment as is, where is, and as development goes on, it will be updated with further updates of the product.